Hello. Today we're going to do momentum. A 1200 kilogram car is traveling eastbound at 15 meters per second when it arrives at an intersection. At the same exact moment, a 1800 kilogram truck traveling northbound at 20 meters per second runs a red light. The two vehicles collide in the middle of an intersection and instantly lock bumpers together, sliding away as a hit single mass. So what type of momentum problem is this? This is known as a hit and stick because they hit each other and they stick. Okay, so they want you to find the final velocity. So final velocity and the direction. So that'll just be part of my velocity, of course. So when we're dealing with these problems, always draw a diagram. So let's draw a car traveling eastbound, so he's going this way, right? At 15 meters per second. And this is just a rough sketch, by the way. And at the same time, a 1800 kilogram truck traveling northbound. So northbound is a bigger truck, longer. Trucks are pretty long, I think. And this is 3D, by the way. Look at that. Oh, I kind of messed it up. It's fine. And he's going this way at 20 meters per second. And let's just remember, this is 1200 kilograms. This is 1800 kilograms. Okay, so we have a good idea of what's going on. And now let's start by writing that because we know, just like energy, momentum is conserved. Okay. And since this is a hit and stick, we know that the two vectors were moving initially. So let's call this car. So let's call this car, and this is truck, T for truck. So the momentum of the car plus the momentum of the truck will equal what's in the end. It'll be a blob of car, so it'll be a blob of vehicle, blob of automobile. Yes. So car and truck added together. That is their final momentum. Now let's draw our vector diagram, or what that's what you call it, right? So we know that the initial momentum, where it starts and ends, the arrows must start and end in the same places as the final momentum. So here is the truck. I'm gonna do this in red. Red, and I'll make it a little bit thicker. So the car's momentum was going eastbound. We know this, and that's here. So this is the momentum of the car. Now I'm gonna do this in magenta. This is the momentum. Okay, wait. I drew this again. I drew this a bit too. Do like this. Move it down. Oh, great. That's just great. Okay, move it down so I have a little more space to draw my other vector, which is the truck. Truck I'm going to do in magenta. Oh, no. Okay. Yeah. Here's magenta. This is the momentum of the truck. Just slightly longer. Oh, no, it should be a lot longer because all the values of the truck were just greater than the car. So this is the momentum of the truck. This is our initial momentum, total initial momentum. Now let's do it in orange for our final momentum, which is starting in the same place. So this was our start point, and ending in the same place. So we draw. Oh, can't draw straight lines. I have problems with straightness. Yes, okay. This is our final momentum, which is also known as momentum of our car and truck. Great. So we have done the hardest part of this. Now, from here things are easier. So let's pick up the calc now, because we know that I'm gonna do this in dark green now. Momentum of the car is equal to, let's look back up here, this 1200 kilograms at 15 meters per second. So 1200 kilograms times 15 meters per second, because we know that P is equal to mv. Very important. Okay, east. Maybe that's important. It is important. Okay, but we drew our diagram anyway, so it's fine. So that is 18,000. I could have done that in my head, by the way, but I just don't want to. I don't want to make you guys feel like overwhelmed by my incredible mental math skills. I just don't want you guys to be like too scared of that, because like, you know, if you wanted me to, I could do a lot of mental math. Just kidding. I'm actually pretty bad at math. Like, I'm actually just pretty bad. I wasn't. I'm just kidding. East. Ah, my units. Don't ever forget your units. Kilogram, meters per second. East. Okay. And, oh, I'm nearing the end of this page. Truck is equal to 1200, 1800. 1800. 1800 at, ooh, you got a sneak peek at the next problem. 1800 kilograms at 20 meters per second north, which is equal to 36,000, of course. Kilogram meters per second north. Well, that makes it pretty easy now, because now we just use Pythagoras theorem to solve for the thing, which is, I'll do this in another color. Oh my god, I am so good at using colors. Yes, yes, yeah. Oh, that's a bit. I'll do a darker color, darker blue. Momentum of the car and the truck is equal to Pythagoras theorem. So 18,000 kilogram meters per second. Okay, like we don't need to. And then 36,000. You don't need to include a direction here, because like you know what you're doing. Yeah. So we do a square root over all of that. A squared plus b squared, blah blah blah. So wait, is my camera blocking this? No, it's not. This is equal to 18,000 squared plus 36,000 squared. This trusty calculator. I love this calculator. I don't know what I'd do without my calculator, you guys. I wish I had a CE. Oh yeah, I wish I had a TI-84 CE, because there'd be more pixels and I can download images. But you know, this is also really cool. Like graphing calculators are so amazing sometimes. Okay, so we only know the magnitude of the momentum. Now to find the angle, what are we trying to find? We're trying to find the angle. Look back up here, angle theta. So how do we do that? Well, of course we use tangent theta. Hey, I'll do another color. I'm sure you guys enjoy the colors, so that's why I'm doing it with so many colors. Dark blue. This is actual dark blue, by the way. Tangent theta equals, that's y over x, which is equal to pt. I'm not going to write that. I can write it all in. Actually, it's fine. Okay. This is equal to 36,000. Yeah, 36,000 kilogram meters per second over 18,000 kilogram meters per second, which is just 2. That's just 2. So this just equals tangent, inverse tangent of 2, which is equal to 63.4 degrees. 434, but how many sig digs are there? There are 2 sig digs. So this actually rounds down to 63 degrees. And here is our final answer, which is, I'll write it up here. Yes. So guys, This means our final answer is, I'll do this in black. Yeah, because black is the most like, it can make statements. So this is our final velocity, which is equal to 40,249. That is 4.0 times 10 to the 4 kilogram meters per second at 63 degrees. And look, this is 63 degrees north of east. Great. And also, if you're ever uncomfortable like with the angle, just remember like, okay, the truck obviously had more momentum than the car, and the truck was traveling north, which means that of course the angle should be closer to north than east because the car had less momentum while the truck had more. So of course then it would be 63, and that would be no doubt at all. So I'll just circle that, rectangle it. Okay, great. That is how you solve hit and stick problems.